In this short video, we're going to have a look at permutations again, but what happens when we have situations where we have repeated objects, so objects that are exactly the same. So previously we looked at the 5 factorial ways, or 120 ways of arranging the letters from the word maths. We noticed that all these letters are different. But how many permutations are possible when we arrange the letters from the word seek? And what we notice in this word is we have a repeated object, which is the letter E. Now we could start actually writing out the different arrangements that we can have. We could have S-E-E-K, obviously, and then we could have S-E-K-E, and S-K-E-E, and K-S-E-E, and then we can just keep going. But if we take a closer look at, say, the first one, what we notice here is I don't actually know which E is being written first or second. Is it S and then the first E and then the second E and the K? Or is it S and then the second E and the first E and then K? Does it really matter? In fact, these are representative of the same thing because an E is exactly the same as another letter E. So this is really classed as one arrangement. If we take a look at the second example we've got here of rearranging some of the letters, what we'll notice that we've got S-E-K-E, but is that the first E and the second E, or is it the second E and the first E? In fact, an E is an E, so this is just one arrangement. So when we have repeated letters, for example, there's no need to worry about arranging these. So what we want to do is remove that need to arrange those two letters, which means that we need to remove 2 factorial. So we think about it in terms of our box. If we put an E here and an E there, if we call that the first one E1 and the second one E2, that's exactly the same as putting E2 and then E1. So we need to get rid of this arrangement. It means that if we have those 4 letters arranged, and we would originally draw our box and say 4, 3, 2, and 1, because we don't have to worry about where the 2 E's are placed and arranging them, our 4 factorial is going to be reduced by the 2 factorial. This is the repeated E that we want to remove because we don't want to count these as separate. What that does to our solution is 4 factorial being 24 and 2 factorial being 2 reduces it to just 12 different arrangements. So let's consider the word isosceles. Now if we have a look in the word isosceles, we have some repeated letters. We have 3 S's this time and 2 E's. So originally, if we arranged these 9 letters, we would say there is 9 factorial ways of arranging them. But because where the 2 E's are, if they get swapped over, that is not counted as a separate arrangement, we need to account for removing that arrangement. So we're going to divide by 2 factorial. This is for the repeated E's. And we're going to divide by the 3 factorial for the repeated S's. So our original 9 factorial is reduced by dividing by what would be 12. So this reduces our arrangements to just 30,240. So just adding this onto your knowledge of permutations and arranging objects, I'd like you to have a look at Sadler Unit 1 Exercise 2B, questions 1 to 6, which are shown below.